Hi students, once again welcome back to our YouTube channel on maths. Today we are going to discuss about conditional probability. Conditional probability. See, you know what is meant by probability of an event. See, let us assume that if A is an event, then what is P of A? P of A is simply probability of happening the event A. And what is probability of happening the event A? It is number of cases favorable to A divided by total number of cases. That is, P of A is defined as number of cases favorable to the event divided by n of A divided by total number of cases. Total number of cases means total number of events in the sample space. For example, let us consider the random experiment of tossing two coins. So what is the sample space? In the case of tossing two coins, it is HH, HT, TH, TT. So this is the sample space of the random experiment of tossing two coins. So what is the probability of obtaining two heads? Probability of obtaining two heads. So probability of obtaining two heads according to this definition, number of cases favorable to two heads divided by total number of cases. So what is the number of cases favorable to two heads in the sample space? In the sample space, this is the one and only favorable case corresponding to two heads. That is 1 divided by total number of cases in the sample space is 1, 2, 3, 4. So 1 by 4 is the probability. So probability of any event is number of cases favorable to the event by total number of cases. And this definition, that is classical definition, is quite known to you. So let us discuss about conditional probability. So conditional probability means P of A given B. So P of A given B means probability of happening the event A given that the event B has already happened. So what is P of A given B? It is probability of happening the event A given that B has already happened. B has already happened. So P of A given B means probability of happening the event A if the event B has already happened. That means if the event B has already happened, what is the probability of happening the event A? So here we are given a condition. That is why this is called the conditional probability of A. See, P of A given B means probability of happening the event A given that B has already happened. So here what is the condition? The condition is that the event B has already happened. So what is the distinction between P of A and P of A given B? P of A simply means probability of happening the event A. No condition is given there. But here it is the probability of happening the event A given that the event B has already happened. So here we are given a condition that the event B has already happened. If the event B has already happened, then what is the probability of happening the event A? That is the meaning of P of A given B. So what will be P of B given A? P of B given A is probability of happening the event B if the event A has already happened. P of B given A means probability of happening the event B given that the event A has already happened. That means if the event A has already happened, what is the probability of happening the event B? So in these two cases we can easily understand that we are given a condition. If one event has already happened, what is the probability of happening the other event? So we are given a condition that one event has already happened. Now let us try to find out the formula for calculating P of A given B. So P of A given B is P of A intersection B divided by P of B. P of A given B is P of A intersection B divided by P of B. See, so you simply understand the rule. So how will you calculate P of A given B equal to P of, just take the intersection of these two events A and B, that is A intersection B divided by, in the denominator we have the probability of the second event B. So P of A given B is probability of A intersection B by P of B. See, we know that what is P of A intersection B? What is P of A? Number of cases favorable to A by total number of cases. So what will be P of A intersection B? Number of cases favorable to A intersection B by total number of cases in the sample space. So what is probability? Number of cases favorable to that event by total number of cases. Total number of cases means total number of cases in the sample space. So P of A intersection B is number of cases favorable to A intersection B divided by total number of cases in the sample space. Similarly, what will be P of B? Number of cases favorable to the event B by total number of cases in the sample space. So here we can cancel N of S. Then you will get number of cases favorable to A intersection B, or number of cases in A intersection B divided by N of B. So P of A given B is P of A intersection B divided by P of B, or it is number of elements in A intersection B divided by number of elements in B. N of A intersection B divided by N of B. Similarly, we can calculate P of B given A also. So what will be P of B given A? It is P of A intersection B divided by. So here what is the rule? Just take the intersection of these two events. So P of B intersection A. B intersection A is nothing but A intersection B divided by, in the denominator we have the probability of the second event, P of A. So here also what is P of A intersection B? P of A intersection B is number of cases in A intersection B divided by total number of cases in the sample space. So P of A intersection B is number of cases in A intersection B divided by total number of cases in the sample space. Divided by what is P of A? P of A is number of cases favorable to A by total number of cases. N of A by N of S. So here we can calculate cancel N of S. So it is N of A intersection B, N of A intersection B divided by N of A. N of A intersection B divided by N of A. So how will you calculate P of B given A? P of B given A is P of A intersection B divided by P of A, or it is number of N of A intersection B divided by N of A. That is number of elements in A intersection B divided by number of elements in A. So what is conditional probability? In conditional probability, we are given a condition. So what is the condition? One event has already happened. If one event has already happened, what is the probability of happening the other event? So if we are considering two events A and B, then what is P of A given B? It is probability of happening the event A given that the event B has already happened. What is P of B given A? It is probability of happening the event B if the event A has already happened. So we have also seen the formula for calculating P of A given B and P of B given A. What is P of A given B? It is P of A intersection B divided by P of B, or it is N of A intersection B by N of B. What is P of B given A? It is P of A intersection B divided by P of A, or it is N of A intersection B divided by N of A. Now I think this concept is quite clear to you. Now let us go through some very simple problems. See, suppose first problem, let us assume that E and F are two events. P of F is equal to 0.2 and P of E union F is equal to 0.7. So how will you calculate? Suppose we are required to calculate P of E given F and P of F given E. So how will you calculate this? So what is the formula for calculating P of E P of E given F? P of E given F is P of E given F is equal to P of E intersection F divided by P of F. We have seen this formula earlier. So P of E given F is, what is the rule? P of, just take the intersection of these two events, P of E intersection F divided by P of, here you write the second event, P of F. So how will you calculate P of E intersection F? To find out P of E intersection F, we are given P of E, P of F and P of E union F. So how will you calculate P of E intersection F? So in order to calculate P of E intersection F, we can make use of addition rule. What is addition rule? See, addition rule says that P of E union F is equal to P of E plus P of F minus P of E intersection F. I think this rule is quite familiar to you. So P of E union F is P of E plus P of F minus P of E intersection F. From this we can calculate P of E intersection F. What will be P of E intersection F? P of E intersection F is equal to P of E plus P of F minus P of E union F. See, here we are given these three quantities directly. P of E, P of F and P of E union F. These three are given directly. So substitute. So what is P of E? 0.6. Plus what is P of F? It is 0.2. Minus what is P of E union F? It is 0.7. So what is this? 0.6 plus 0.2, 0.8 minus 0.7, that is 0.1. So P of E intersection F is 0.1. Now you can make use of this formula. So what is P of E intersection F? P of E intersection F is 0.1. So this is 0.1 divided by what is P of F? P of F is 0.2. That is equal to 1 by 2. Multiplying numerator and denominator by 10, you will get 1 by 2. So similarly we can calculate P of F given E. So how will we calculate P of F given E? So P of F given E is equal to P of F given E is equal to P of E intersection F divided by what is the second given here? It is P of E. P of E. Simply substitute directly. So what is P of E intersection F? P of E intersection F is 0.1. 0.1 divided by what is P of E? It is 0.6. Multiplying numerator and denominator by 10, you will get 1 by 6. So I think this problem is clear to you. So here we are given two events E and F such that P of E equal to 0.6, P of F equal to 0.2 and P of E union F is equal to 0.7. You are required to calculate P of E given F and P of F given E. And we know that for calculating P of E given F and P of F given E, we need P of E intersection F. So first of all, P of E intersection F is to be calculated. So how will you calculate P of E intersection F? For that we can make use of addition rule. What is addition rule of probability? It is P of E union F equal to P of E plus P of F minus P of E intersection F. From this, what is P of E intersection F? P of E intersection F is equal to P of E plus P of F minus P of E union F. These three quantities are given directly. So substituting, you will get P of E intersection F is equal to 0.1. Now we have the formula for calculating P of E given F and P of F given E. So directly substituting, we will get P of E given F and P of F given E. Is it clear to you? Now let us discuss one more problem. See, second problem. See, let us consider the random experiment of tossing two coins. Two coins are tossed. Two coins are tossed. So, what is the probability of obtaining? What is the probability of obtaining? Probability of getting two heads if there is at least one head. What is the probability of obtaining two heads if there is at least one head? So how will you calculate this? See, in any problem of probability, first of all what you have to do is you have to identify the events in the problem. So here in this problem two events are there. What are the two events? Event of getting two heads and event of getting at least one head. So the two events are event of getting two heads and the second event is event of getting at least one head. Now let us name these two events. Let this event be event A and let this be event B. That means let us assume that A is the event of obtaining two heads and B is the event of getting at least one head. So what is meant by event of getting at least one head? At least one head means number of heads should be greater than or equal to 1. Isn't it? At least one head means number of heads should be greater than or equal to 1. That means we must get at least one head. So these are the two events. We are required to find out probability of getting two heads if there is at least one head. So this is the condition. What is the condition here? B is the condition. You are required to calculate the probability of the event A. So clear? We are required to find out the probability of getting two heads if there is at least one head. That means this event B has already happened, or this is the given condition. If the event B has already happened, you are required to find out the probability of happening the event A. That means P of A given B is to be calculated. Isn't it? So how will you calculate P of A given B? So for that, what is the sample space of this experiment? So the sample space is, the random experiment is event of tossing two coins. So what is the sample space? Sample space S is equal to HH, HT, TH, TT. So this is the sample space. See, in this sample space, the event B has already happened. The event B has already happened means this is the condition. There should be at least one head. There should be at least one head means what are the favorable cases? The favorable cases are HH, HT and TH. Here there is no head. So this case cannot be considered. The event B, the condition is that there should be at least one head. That means the number of heads should be greater than or equal to 1. Here the number of heads is 0. So this event cannot be considered. So our new sample space reduces to a set of 3 events which are HH, HT and TH. See, out of these, how many are favorable for 2 heads? Only one is favorable for 2 heads. So the required probability is nothing but 1 by 3. P of A given B is nothing but 1 by 3. But how will you calculate this using the formula? So what is P of A given B? P of A given B is equal to P of A intersection B divided by P of B. So how will you calculate P of A intersection B? So for that, what is the event A? A is the event of getting 2 heads. And what is that? Set HH. And what is the event B? B is the event of getting at least one head. Event of getting at least one head means what is the set B? HH, HT, TH. HH, HT, TH. This is the set B. And what is A intersection B? intersection B is the set of all those elements which are common to both the sets A and B. That is set HH. Now we can make use of this formula. So what is P of A intersection B? P of A intersection B means number of cases favorable to A intersection B by total number of cases. What is the number of cases favorable to A intersection B? Here is only one case. By what is the total number of cases in the sample space? 1, 2, 3, 4. So this is 1 by 4. And what is P of B? P of B is number of cases favorable to B by total number of cases. So what is the number of cases favorable to B? It is 1, 2, 3. By what is the total number of cases? That means total number of cases in the sample space is 1, 2, 3 and 4. So this is 3 by 4. Cancelling 4, you will get 1 by 3. So without using this formula, we know that the answer should be P of, that answer should be 1 by 3. So how would you know this? See, we are considering the random experiment of tossing 2 coins. We are required to find out the probability of getting 2 heads if there is at least 1 head. So these are the 2 events. A is the event of obtaining 2 heads and B is the event of getting at least 1 head. So this is the condition. So in the case of tossing 2 coins, this is a sample space, and what is the condition to be satisfied? There should be at least 1 head. So what are the favorable cases corresponding to B? These 3 are the favorable cases. So our new sample space is the set containing only these 3 elements. We should not consider this one, TT. So what is P of A given B? See, out of these 3 cases, what is the probability of obtaining 2 heads? Out of these 3 cases, only 1 case is favorable to 2 heads. So the required probability, that is P of A given B, will be 1 by 3. Let us consider one more example. Suppose we are considering or we are drawing a card from a pack of cards. Suppose we are drawing a card from a pack of cards. Then what is the probability of obtaining an ace if a red card is obtained? It will be a third problem. During the random experiment of drawing a card from a well shuffled pack of cards. Then if a red card is obtained, what is the probability of obtaining an ace? Here also 2 events are there. What are the 2 events? A, let us assume that A is the event of obtaining an ace card and B is the event of obtaining a red card. We are required to find out the probability of getting an ace if a red card is obtained. If a red card is obtained means the event B has already happened. See, if a red card is obtained, what is the probability of obtaining an ace? That means event of getting red card is already happened. Then what is the probability of happening the event A? So here in this case you are required to calculate P of A given B. What will be P of A given B? See, we know that in a box of cards 52 cards are there. In these 52 cards 26 are black and 26 are red. See, on drawing a card from a pack of cards, we are given that a red card is obtained. See, red card is obtained means we need not consider these 26 black cards. We have to consider only these 26 red cards because we are given that a red card is obtained. So since it is stated that a red card is obtained, we need not consider the black cards, 26 black cards. Then what is the probability of obtaining an ace? So from these 26 red cards, what is the probability of obtaining an ace? See, in these 26 red cards, how many ace cards are there? In 26 red cards, 2 ace cards are there. What are the 2 ace cards? That's it. 2 ace cards are there. Diamond ace and heart ace. So 2 ace are there. So 2 divided divided by what is the total number of cards? Total number of cards is not 52 here. Total number of cards is 26. So the required probability will be 2 by 26. That is 1 by 13. Or by using this formula, what is P of A intersection B? P of A given B means it is P of A intersection B divided by P of B. So what is P of A intersection B? Probability of happening both the events A and B. Both the events means it should be an ace card as well as a red card. So what is the probability of obtaining both ace and red? What is the total number of cards corresponding to this? Total number of cards which are both ace and red are 2 cards. Isn't it? 2 divided by total number of 2 cards. What are the 2 cards? Diamond card and heart card. So 2 divided by total number of cards is 52. 2 by 52. Divided by what is P of B? P of B means probability of obtaining a red card. What is the probability of obtaining a red card? Total number of red cards 26 divided by 26 are the total number of red cards by total number of cards is 52. So cancelling 52 we have 2 by 26, that is 1 by 13. So it's clear to you? See, for the time being this is enough. In our next video we will discuss more problems on conditional probability. Till then, bye.